Sorry, I will start recording here. Sorry if you're joining us here. But Zach, go ahead. You had a question?
They're co-related, so quad 2 is pi minus theta.
Mm-hmm.
For quad 4 it's 2 pi minus theta. For quad 3 it's oh no, we're not subtracting it from y-axis.
Correct. We don't have to worry. Okay, so as a quick recap, this is just using regular cast rule. We isolate it for the x value. And where do we go from here to solve equations? Well, the best way is to calculate what quadrant we're dealing with and what the related acute angle is. We've established that it's quadrant 2 and 4 because the answer was a negative. It has to be quadrant 2 and 4. And if this was a positive, in other words, if this happened to be in quadrant 1, my related angle is going to be 0.322 radians. And so we apply that to quadrant 2 and quadrant 4 within a single circle. But I'm not done. If you take a look at the domain, it pushes on to 3 pi. So if we are dealing with the next pi rotation, without me saying anything, without me drawing anything, what quadrant do we have to consider once again? Got 2 hands. Think about it. I will answer it myself, but if we're doing another pi of a rotation, which quadrant do we have to consider for another answer? The answer is from 2 pi to 3 pi, we are rotating another half of a circle, which means we're only dealing with quadrant 2 this time. Again, rather. Okay? And in quadrant 2, you could think about the angle to be coterminal with this one, or you could think about this as a full rotation plus another one of these. Well, I guess that's actually the same thing. Okay? So this is going to be 2.82 radians, because that's where this is, plus a full rotation. Which is approximately 2.82 plus 2 pi is about 9.10 radians. And at this point, some of you are still copying, others might be ready to move on. I'm going to challenge you to think about the interval from negative 2 pi to 0. Because if you go back to the original question, it asks for that negative side as well, right here. What is going on? Spam. I'm going to put this on silent. Okay, right? The domain specifies that I'm going backwards in rotation to another negative 2 pi. So if I'm going from negative 2 pi to 0, what quadrants would that include? And then find the angles for that. How you do it is up to you. You could think about it as coterminal, or you could think logically and be like, oh, I'm going backwards by this many angles. This must be the answer. Either one, I am okay with. I'll give you a minute. I'm going to pause this video so that we can save time. Okay, I'm going to resume the recording. If it's rotating a full circle backwards, well, it's going to involve quadrant 2 and quadrant 4 again. As a side, you may not need me to do this, right? But if I'm going backwards on a sine curve, I'm talking about this part right here. And if you think about going backwards, this does include quadrant 2 and quadrant 4. Right? Another way you could think about it is, If I'm going backwards, a full rotation, it passes through quadrant 4, it passes through quadrant 2, we're going to have two answers. So, quadrant 2, my angle would be, once again, coterminal with 2.82. That would be, which is approximately, my answers are negative 3.46 radians. And in quadrant 4, I have theta being coterminal with 5.96 radians. And that would be yes, it would be negative 0.322 radians. But hey, doesn't that number look familiar? It was our original acute angle. So instead of thinking about this as coterminal, if you think about this as, oh, well, I know what that triangle is. It's the same angle as that one. But instead of going in the positive direction, I am simply going in the negative direction. So that's why we have a negative 0.322, and it works, it makes sense. So whether you do it in a logical fashion, just thinking about it and stating it, or you think about it in a coterminal way, it's all the same to me. So do what makes sense for you. Yes, Sam?
So the starting line that you gave goes to 3.5.
Mm-hmm.
And like you did it as like one full rotation and a half.
Uh-huh.
But how do you know like the thing wasn't like doesn't have a K value and the period isn't like 3 pi already? Like you look at that?
That's why I love you being here, Sam. You're asking all the right questions. There are situations where there's a K value. And so I will teach you how to adjust for it. For now, take a look at the original question. We were trying to figure out when tan x equals this. So this simplified equation doesn't have a K value. So you don't have to worry. But what if it does? What if there's a 2 here? Where have you seen 2x before? The formulas, double angle formulas, you're right. So when that happens, there's something we need to do. But let's make sure we're comfortable with just this. Because from that question alone, we have how many answers? 1, 2, 3, 4, 5 different answers. And they all have to be stated. Because they all make it true. Alright? Let's try this. I'm going to pause this video after asking you to try. Please try. Where's my other sheet? Try example 4. Now, I'm going to start example 4 for you because it might look a little different from your other questions. But once you see where this is going, I hope you can do the rest. Here we go. Sine squared minus sine equals a 2. Ooh, how do I get x all alone? Well, this you can't, but that should look familiar to you. Any thoughts? Any creative thoughts? What does that sort of look like? Jesse?
No, I don't know what it is, but it looks like something I've seen on the sheet. So.
It looks like one of the questions. It's true.
Is it, wait, sine 2x sine x
Equals 2. Consider this. Don't worry too hard. This is what I wanted everyone to draw a parallel to. This is going to be very hard to isolate for just x. Why? Because if you want to isolate for sine x, or sine squared, you have a sine x on the other side. If you isolate for sine x, you're going to have sine squared on the other side. Can't do anything. But you might recognize that this is very similar to, Vita, what's your favorite letter? Letter of the alphabet.
Oh, I don't know. B.
B, sure. Let B that look familiar to you? It's a quadratic.
Oh my god,
It's back. Yes. Yes. So these are techniques and tools. Yes, it's math, but it's more just speaking that language, and all that practice is necessary so that it comes out very naturally as you continue on in this journey. So, product sum. There we go. And at this point in time, you can say, therefore, B has to equal 2, or B has to equal -1. Okay, finish the question. So when you get a question like this that involves both a power of 2 and a power of 1, or exponent of 2 and exponent of 1, you're going to have to be a little creative. But it's not impossible. Go ahead. I'll give you a couple minutes to finish. Alright, so again, this question shouldn't take you too long. Because there's a little bit of a trick. Yes, the domain is a little bit large. It's supposed to be 2 full rotations. But take a look. First case, sine x equals 2. Not even undefined, it's impossible. Right away, you can reject it completely. Why? Sine curve? What do you know about the sine curve from 5.1, 5.2? There you go. This is actually impossible. Therefore, you will reject right off the bat. It's impossible. The calculator will give you an error. That's your indication that, oh, something is wrong. There's no angle that makes this true. Yes?
Does that mean as long as sine x will never be equal to greater or less than like 1 or -1?
Correct. When will think about this. This is y over r. When will the opposite side ever be bigger than the hypotenuse of a right angle triangle? Never. It doesn't make any sense. That's right. So, let's focus on case number 2. Sine x equals -1. Think about this. There's only one situation, one location, when the sine value is equal to -1. What angle? Yes. Plus every rotation of that. So, x is going to be 3 pi over 2, as well as the next rotation, right? In one circle, this gives me a sine value of -1. Sine x equals -1. When else will you get a -1? Well, after one rotation, that, right? That will also, because it's coterminal. So x is going to be 3 pi over, oh shoot. X is going to be 3 pi over 2 plus another full circle. It is going to equal 7 pi over 2. 2 answers. Yes? Yep, okay.
So we don't have to do anything with 3 pi over 2. Just
Yes, for this one, there's no cast rule if you're asking. There's only one angle that gives you a -1. So there's no need to decide whether it's quadrant 1 or quadrant 2,
so in
or quadrant 3 or 4.
5.4, we're only going to be using coterminal angles.
Cast rule with coterminal angles, yes. You don't need. I don't think you'll need
Which
cofunctions.
is basically just adding or subtracting from the x-axis.
Correct. Yes. Sorry. Would it work?
Would it work if you wrote 3 pi over 2 as -pi over 2?
No, because the domain must be greater than 0. The answer is the same, So the angle does make this true. It does work by answer, but it has to fit between 0 and 4 pi. And so, because if that was true, then you can state every single negative angle on the left side and every single positive angle beyond 7 pi over 2.
No, but it's in like either quad 3. Because if you didn't, then you could just use.
Oh, I see what you mean. What I meant by quad 3 or quad 4 was that I don't have to worry about whether it was, which direction, what negative or positive, whatever. There's only one point within a full circle that this makes sense, that makes this true. So I don't have to worry about this. All I have to worry about is every rotation and how many rotations I do. I get what you're saying. Okay? Any questions on that? Yes.
If the third domain is continued,
Mhm.
so let's say, just under 5 pi. So like, I can't think of a fraction off the top of my head, but whatever, like 4.95 is. How would we say that last almost half rotation doesn't, or I guess 5 pi would work. So let's say it's 5 pi. How would we say that the last half rotation doesn't meet the thing? 'Cause it would
5 pi. 5 pi as in an extra rotation? So 1, 2, 3?
Yeah,
So if it was like that,
it would still be 2 answers. So how would we say that last half rotation doesn't have?
well, I'd be happy with you just saying it doesn't reach, what is it called? So this would be 5 pi, and this would be 11 pi over 2, which is greater than 5 pi. Just say that it's beyond 5 pi, so you don't need to, yeah, just communicate. Yes, Maggie? You are, pardon?
Like I'm not saying this was saying that to like values and access and when I put it in my calculator.
What are you getting?
Basically just because
It says like 1/2 pi.
Negative 5 or 2.
so when
Yeah, it says, so if this one says pi over 2, just,
Negative pi over 2?
yeah.
That is a smaller absolute value. Correct. So if I did it by a graph, so this is the funny thing about the calculator. Right? If I want to know when the value equals a -1, from the y-axis, which side's closer, left or right? If I'm right here, the left side is closer. So the calculator will give you the closest number, closest absolute value. But since the question is asking from 0 to 4 pi, you have to give me that one instead. In other words, I would suggest that either you understand based on just a Cartesian coordinate that this is going to be my -1, or look at it graphically so that you can transfer over, or I don't know, you can figure it out.
Yeah, no, I
Yes, Zach.
Did you mention in your calculator what -5 or 2 is? Just add 2 pi to get the
Correct, because they are coterminal. Yep, you can, if you have this, you can add 2 pi or whatever the period actually is. If it's just 1 pi, then you add 1 pi, so on and so forth. Okay? So, here's what I would like to do. I really do want to get to example 3 because it gives you an opportunity to work with a double angle formula, although we don't have to actually, I think the solution gets us to simplify it instead of worrying about you know what? No, it does. I'm going to stop right there. Maybe I'll give you a taste of how to work with a double angle formula at the end of class, but I think it's better to leave it until tomorrow morning, giving yourself an opportunity to practice over the next 30 minutes. All right, I'm gonna give you a handout. It has all the answers in it. There is one correction I need to make so that you don't get confused at home. And when you come back tomorrow, I hope most, if not all, of these questions are done. The handout I'm going to give you, it has a whole bunch of questions in it, but I only want you to do the top half, because the bottom half starts getting into the funky business. All right, I'll pause this video here.